So I'm recording, I hope. Yeah, I want to make sure I record all these. And you all can see a screen now from homework 21 in place of quiz. Okay. How many participants do we have right now? 19. I think we have either 27 or 28 people registered still. We had 26 at the last meeting. We'll wait a few minutes. It's still early. Before we start, you can only see the screen I'm casting now. You can't see me, is that right? Okay. And 19 people. Let me get this. With that in mind, I had a discussion with several people last night about how to go about the homework. If you look on the screen here, this is the actual DTFT for the second one right here. And I literally, the only thing it changes, the limits go from -2 to +2. This is the kernel, e to the minus j and omega. And that, using the geometric sum, it comes to this right here. Can y'all see that, what I've highlighted? Okay.
Yeah, we can.
Does everybody realize how to get that? This is using the geometric sum, right? And then what I've done is factored out, to do this right, you add the superscript here, that e to the j2 omega, and the superscript here, e to the minus j3 omega, which is minus j omega, and divide it by 2 and factor that out. This is the trick with all this factoring, to get sines or cosines. And same thing at the bottom. This is really e to the 0, and then this is e to the minus j omega. Add them together, you get e to the minus j omega. Divide that by 2, it's e to the minus j omega over 2. Factor that out, and I get this on top and this on the bottom, right? And then, just so we don't lose anybody, I know that the sine of, I'm just going to use x, sine of x is equal to e to the jx minus e to the minus jx, and this whole quantity divided by 2 j, oops, well, you get the idea. Anyway, you take this, and the x here is 5/2 omega for this one. So when you do that, you put the 2j on this side, get rid of it here, and then you simply substitute 2j sine of 5/2 omega on top and 2j sine of omega over 2 on the bottom, and you get this. We talked about this last night too, right? Now, what that is the actual formula. It's right here. The top one right there. Do you see it? And this table, you're going to have available to yourselves. These are the basic functional forms. I'm going to say one other thing. I'm going to do something where I show, I gotta shut this off, where I show how to use duality with a DTFT, and using known Fourier transform pairs, we can get the DTFT Fourier transform pairs. I'm going to do some of that today. And then the second thing I'm going to do is try to answer your questions about MATLAB and sampling. Okay, so how many do we have in the meeting now? We got 22. I'm trying to wait until all of them Well, technically we started. We'll got 24 or almost there. We'll start right now. So for starters, does anybody have any questions?
Can you go over the sampling problems?
The what?
The sampling problems?
Is the one you're talking about this one? Number one?
No, number 5.
Number 5? Oh, all right. We talked about this last night. So let me put that equal sign right here. Here's what it amounts to. I'm going to try to break this out. I'm going to copy this and just take it down. I'm trying to do this because it's a little neater. Maybe it'd take a little longer. So now what I'm going to do is say, I'm going to sample at t equal n times t sub s. I know it looks like in MATLAB, it's an asterisk to do multiplication. We'll actually do this on MATLAB too, all right? Was that you, Ruth?
Yes.
All right, so that means now when I get that, what do I get? I have x of n ts, I'm just going to leave it ts like that, equal to 2, and then it's going to be e to the minus, and now it would be 2n ts, right? I'm replacing t by nts because we're sampling at a certain time interval, which is ts, those help the spacing, and n is an integer value. And then it's going to be times cosine of 10, and now I'll just put nts here, right? And it's u. Remember, the u of t function, it just matters if it's 0 or negative or positive. So you can just put in u of n. And I think you can all see that, right? Okay. Try to get more of you up here. Blow that up. That's a pain. I'm trying to see the reactions, and this window is minimized. Hold on. I can see some of you now. Okay, that's enough. I think I can see 1, 2, 3 people. There may be more showing, but that's good enough for now. Anyway, getting back to this. Now what we do is take this and suppress the TS anywhere that it's not needed. So here, let me get this one. And I'll tell you one other thing. Formally, what they do is just put square brackets normally. And now what I do is get rid of the TS there. And I'll even do, this is the way it usually is. They would put square brackets and put n in there. And then they would go ahead, and here, what they're going to do is multiply 2 times TS and take the n out. So you have 2 times TS here. Let me bracket that and I'll explain something. 2 times TS minus TS. And then that would be to the nth power. Come on. I have to do it this way. I'll explain why I'm doing it this way. Why isn't that doing the superscript? Oh, I know, because this stuff's here. It's supposed to be to the nth power. And it's times cosine. And here, what you're going to do is take 10 times NTS by itself. That'll be a constant, and then it's times n. So that will be the coefficient. That's omega naught right there, 10n. And then it's times u of n. Now, clean that up again. I have x of n equal to 2a to the n x of n equal to 2a to the n times cosine, and now it would be omega naught times n u of n, with the condition that a is equal to e to the minus, a is equal to e to the minus 2ts, and omega naught equal to 10 ts. Y'all follow me on that?
Yep.
All right, who's up? Are you there? I'm looking for Ruth. Is that you asking, or who's asking?
Yes. Yeah.
Right.
I'm good.
All right. You see, that's all the only thing I've done here.
Mm-hmm.
And now that is the form that we know, right? That's a form that I think I have up here. I might be wrong. Where's, oh, it's not in this table, but in your book. Let me get my book. This is one I actually gave you, I think, but I'm not absolutely certain. If you look on page 398 in the book and go down, it's the 8th value. They have a to the n cosine of omega naught n plus theta. The only thing you do is make theta 0. And if theta is 0, then you get the transform down on number 8. Do you all see that?
Yes.
You have your books, page 398. Do you all see how that's exactly the same thing?
Mm-hmm.
Yeah.
All right. Well, it's important you do see it, because that means that this effectively, we've got the transform for that. We can do it if you want to, but we could get it with modulation, right? Just so you're thinking about the properties always, right? And simply put, I know that if I have a to the n, right, times u of n, that's simply, the property says it'll transform as 1 over quantity 1 minus a times e to the minus j omega. Right? That's in a that's when you have to know kind of. Well, if I've got this property, then multiplying by cosine is just modulating it, and you could do it that way. With me?
Yes.
All right. Can I get thumbs up?
Yeah, that makes sense.
What I'm doing right here. Just put the thumbs up in that thing. Okay, 2, 3, 4, 5, 6. At least I know you're there.
Did he freeze for anybody else?
Yeah, I think he left and is coming back because he couldn't figure out how to unfreeze. Because it says someone else is the host now.
Yeah, it looks like he's back now.
No, this is on my. Hey, I'm sorry. Can you still hear me, guys?
Mm-hmm.
Yeah.
I don't know. I think there's a lot of traffic right now. My neighbor I know is using Zoom for some conferences he has. And I think the Auburn school system is working up where they're going all online. So if this gets interrupted, just hang on.
Does it freeze again for y'all? Or
Yeah.
okay.
He's gone.
For us.
What did you say?
Oh, you're back. You froze for a second there.
Oh, yeah, I got a bad feeling about this. I think there's a lot of heavy data traffic on Spectrum in my area, and that's what's doing it. I understand the Auburn school system is trying to get all their stuff on Zoom too. I don't know how well they're getting it there, but that's going to cause a lot of disruption. Anyway, if I do freeze, bear with me. Anyway, getting back to this, Ruth, did that answer your question?
Yes.
Now we can take this, if you're asking about how to plot this in MATLAB, which is a logical thing, right?
Can you share your screen again?
Oh, it's not shared?
No.
Sorry. My bad. I'm assuming it just picks up where it left off. And if there's any problem, let me know. Now what? Can you still see me?
Yes.
Yeah, that's working.
Are you seeing the screen too or not?
Yes.
Yeah.
Okay, you're seeing the yellow. All right.
Yeah.
So we were talking about this.
So this is going well.
Oh boy.
To be fair, though, it's not his fault we can't hear him.
That's true.
Right. I mean, nothing you can do about lag and traffic. So.
Yeah.
Were the videos from last night or any of the other lectures ever posted for him?
Not yet, I think. So, unsure. He didn't send a link or anything, to my knowledge. But
I'm uploading and processing the video from last night right now, and then when it's uploaded, I'll send a link to it.
Appreciate that.
Nice.
How long were y'all on with him last night?
About an hour.
yeah, an hour.
Rip.
This is fun.
So does anybody else have to drive back to Auburn to get a bunch of their stuff so that they can live for a little while at home?
I'm going to be leaving after my next class. To go grab everything out of my apartment.
Yep. I got a 20-hour drive this weekend, so looking forward
Big
to that.
oof.
Rough. Sorry, Jack.
Yeah.
Are we back?
All right.
Yep, we're back.
All right. The next time if this goes out again, I've just shut down everything on my computer that in any way, shape, or form could be using bandwidth, except for this. And what I'm going to try to do now is say that, oh, that's the other thing I wanted to tell you about. I went back to 22, this DTFT and DFT and DTFT lecture that I have. Oh, I got to share the screen. Sorry. My bad. Let me share it now. Tell me if you can see a screen with a video link in front of you.
Yeah, we see it.
Yeah, we can see it.
All right. Have y'all watched that video or not?
Parts of it.
I watched, parts of it, most of it.
I'm going to actually put a couple other video links on there. that I think will help a lot. They're just in there. Can you see the progression of? You can go from that lecture to the next lecture. Do y'all see that? How to do that on YouTube? Okay, just thumbs up if you can. I'm trying to blow the screen up too. Okay, got a lot of thumbs. Come on. If this blows out again, what I'm going to ask is everybody to just get rid of your picture and just audio, because that might be a capacity problem too. It might help reduce it, but don't do it now. It's okay. Because I was just out of a Zoom meeting and we had at least 40, close to 50 people on there, and there was no problem. So I don't know. I think this has to do with the route I'm going through Zoom, because it wasn't going through the link with through the president's Zoom connection. It was going through the link at the OIT center, I think, but I'm not sure. Anyway, if you watch that video right there, it'll probably answer some of your questions, but I want to answer as many as I can in person. Now, you asked about this right here and the homework 21 about this. Is that good enough, Ruth?
Yes, that's good.
And you can plot this. You just define omega naught as 10 TS, and then A is e to the minus 2 TS, and you have the transform for this in number 8 in the book, okay, on page 398. And you can, you know how to plot this and run this in MATLAB, don't you?
Mm-hmm.
Everybody? If you do, can I get a thumbs up? I'm looking to see. Tell me how many people are awake too. Okay. All right. If you're looking for that, I think it's in the lower part of the screen on yours. Is the emotions at the lower part of your screen?
Yeah, it's like the lower middle.
Yeah, it's under reactions.
Okay. I'm trying to answer any questions. If you have questions, if you put it to the chat room, probably I can see it and answer it. It would be easier doing it that way on the Zoom session than by email. But you can email me. And as a matter of fact, I'm going to start paying attention to GroupMe. So if I see a lot of concern, I'll try to jump on and deal with it there. And now, what other questions did you have? We can plot that if you want. Anything else? Did you all get the homework then?
I think it'd be beneficial if you could plot the example you just did in.
All right. Tell you what, I've got to go and get my MATLAB connection established. I got to get secured CRT. So bear with me for a second here. Can you see that College of Engineering thing come up too? You could probably see this, the whole screen, right? Okay.
There's also a request in chat to work one out by hand as well.
All right, I will. And now, one of the problems they're having is there's only so many MATLAB FlexLM licenses. So I hope I get one. If not, I'm going to just go to Python or Octave and quit messing around. Because it's irritating when all of a sudden MATLAB just shuts off because the FlexLM license expires. And everybody here has access to MATLAB, don't they? Or Octave, if you're using Octave.
Someone in the chat said that they didn't in the poll. So
they didn't have Octave or MATLAB?
One person did. I'm not sure who it is.
All right, well, Octave is free. And is anybody here using Octave?
Yeah, that's all I have access to.
Could you put a link in a GroupMe thing so people can see where to download it, please? And I'll even use Octave too. Not right now, but I will.
I know we went over installing Octave during our lab session. I'm not sure if some people haven't been to lab yet, but.
Yeah, that's where I just downloaded it from lab yesterday. So.
You have any problems with it?
It seems to work fine.
Okay, well, since somebody asked about plotting that very thing, what I'm going to do is I will just get rid of all this and do it from scratch here. let's just take care of everything so you can see when done from scratch. First, you have to have a functional form, and my x, and I'm just going to put it here. Whenever you put a percentage sign, it's a comment. I know that x here is going to be equal to 2 times a to the n times the cosine of omega naught. How about if I just use OM naught or OM, and it's times n, right? And it's u of n. That's basically what we have here. Now I'm going to go ahead and just create some things. I'm going to just say the sampling rate. Better yet, here's how I would do it. This is how I'd really do it. I'm going to go ahead and first talk about the number of points I'm going to actually sample or use. And this is going to be a big number, and always make this 2 to some power n, where n's an integer. And it's because of the FFT that I'll get to hopefully today. So this is going to be 2 to the capital N. Oh, sorry. Let's do it this way. Make n equal to, say, 10. And no, better yet, call that m. And then make n equal to 2 to the m. And that's going to be a lot of points. What's that, 1024? Now I'm going to go ahead and say this, and watch everyone. I'm going to create the effective time, the sample time. I'm going to say t is equal to the linear spacing. That's lin space, and this is being recorded so you'll be able to see it. And I put the lower limit. It starts at 0, and it's going to go to TF. Now I haven't defined TF, but for that one, it was e to the minus 2t. So it's damping out at a rate of minus 2t. And if 2t is equal to 5, it's basically extinguished. I'm going to go beyond that. I'm going to let TF be equal to 5. So it's 5 seconds. And now the next thing you put here is the number of points. The number of points is n. The next thing I'm going to do, since somebody asked, I'm going to find out what the sampling interval is. Well, that's simply TF divided by the number of points. Does that make sense to everybody? You can give me the thumbs thing if you're there.
Yeah, that makes sense.
I kind of like this. I can see, tells me a couple things, tells me who's actually on too. But if you can see this, go ahead and just okay me there. Now, after that, now I'm going to go ahead and I do this, like people have different ways to do it. I'm just going to say, I'm going to let n be equal to 1, 2, and then I'm going to go all the way out to n. Then n is there. And now I'm going to go ahead and say that my x is equal to 2 times, I'm going to put an index here. I don't have to, I don't think, but I'm doing this for a reason. It's a function or 2 of n. And at this point, I'm going to define a, and a was what? exp to the minus 2 times ts, right? Oops, I got to get below ts. I need to do this stuff right here. Let me pull that window down. So now I'm going to say that, remember, a is that constant, and that was equal to exp to the minus 2 times ts, right? Y'all remember that? We had that, and then the thing we need is omega. I'm just going to use w, just w0. That will be like capital omega 0, and call that equal to, that was equal to 10 times ts, right? Tell me if I'm right. Okay. Y'all know what I'm doing here?
Yep.
And then I'll go ahead and get x down here. That's 2a to the n. Now put a dot there times. Otherwise, you're going to get matrix multiplication, will cause problems. then cosine, and that's cosine of omega naught right there, times n. Everybody okay with that? I think it's the same in octave. I don't think there's any, it's seamless, should transition perfectly. But this is MATLAB. And if you're doing it in octave right now, tell me if there's any problems. You might as well just follow along with this if you have the ability to. Now, after that, I'm going to just plot this to see what it looks like. So I'll plot simply n comma xn, or just x. You don't even need that. And I'm just curious what it looks like. So I'm going to run it. I may get an error here. I did. Error line 16. I have to put a dot there. Y'all see that? I think I do. I think that's it. Okay, so that's a damped exponential. Now the one thing you'll notice, it's about dead right here, correct?
Mm-hmm.
All right, so we've gone, and we could put time here if you wanted. That's another thing. If you want to plot this instead of n, it could be n times ts, right there. Or you could just put t, actually. What am I saying? You could just put t down. We have that. And then if I run it, looks like this. And I might as well, for completeness, what do I do if I want a grid? Anyone?
Grid on.
Grid on. All right, let's think about that. And if you just want to run that command, you can just, if you want it, no, I'll run the whole thing. It only takes a second. And there it is with the grid. I might as well go through the whole 9 yards. Now, suppose you wanted to label the x-axis. Anyone?
X label.
X label.
Yeah, it's always going to be label, X label. And then you have to put parentheses and then 1, just an apostrophe, and then whatever you want to call it. And that's going to be omega, right? Now, MATLAB does something kind of neat. I mean, not omega n. Or no, this is time. Sorry, time in seconds. And then Y label. And that is x of n. And you can put a legend too. And the first we'll put, oh, we just have one thing there, so just put x. What problem? What? Oh, my legend's wrong. We'll just get rid of that for now. When we have more than one plot, we'll talk about that. You don't need a legend with just one plot, but this is what it'll look like, hopefully. All right, so that's just a function. You can take a look at it. I think everybody's got that down. Next, after that, we want to do a couple things today. When we get the DFT of this, we do it manually. We didn't do it symbolically, or we didn't actually brute force it, but we could, and we're going to get there today. But the next thing, if you wanted to plot the DFT, we could plot it. But in light of the fact that what I wanted to do today was show you the DFT and the application. Are there any more questions about the homework before I continue? It was just straightforward sampling and showing, right? Getting the DFT and plotting it. And we can plot that very easily. If you'd like me to, I will. Say again.
Could you do that?
All right. Well, what was the DFT for that one? If you look on 8, let me reduce that. Give me a second here. And 8, it was simply equal to e to the j 2 omega, and then it's minus a
e to the minus 3j omega. That one?
I'm going down here at 8, and 8, it's e to the j 2 omega cosine of theta. Well, theta is 0, so it's e to the j 2 omega minus a, all right, minus a, and it's e to the j omega, right? Times cosine of omega naught minus theta. So it's cosine of omega naught, which is 10 TS, correct? And we've got omega naught there anyway. Then it's all over e to the j 2 omega minus 2a e to the j omega times cosine of omega naught, whatever that is, plus a squared. Are you with me with that one? I just wrote it down, so I'm going to go ahead and plot this, and I'm not going to do it. I'm going to just do it according to the analytics. So I'm going to call capital X, and I'm just going to use small w here to indicate omega. Somebody's got a question?
Nope, we're good.
Okay. If anybody does, just tell me. So that's equal to, matter of fact, let me do this. I want to create a variable. I'm going to call this z is equal to exp. Let me first do omega. I want omega to be equal to, let me see here. It's 2 pi divided by n times, or just divided by n, and then it's times, and we'll use that. And then we're going to say, I'm going to create the variable z is equal to exp to the j times omega. And then that's effectively something I'm going to use over and over again. And then I'm going to say my capital X of omega is equal to z dot squared minus a times z times, I should just do this one time, but I'm not going to, cosine of, no, I will. I'll tell you what. I'll put in W naught here. So it's only done one calculation though, so it's a to the 10, or really to the omega naught times n. And then it's divided by z squared, z dot squared, minus 2 times a times cosine of omega naught. I could put that in as a single value, but I'm going to leave it that way. Plus a squared. Did I need that one or not? I got closure there. I don't think I need that last one. And then I'm going to go ahead and plot omega versus ABS. Remember, you got to plot magnitude and then phase. So I'm going to do ABS of X. And if you hit Control R, you highlight a region, hit Control R, it'll put the comments, the commentary thing. And I'm just going to run this and see if I run into errors. All right, I got an error in here dimensionally. Let's see. So let me see if I can do z dot squared.
Should it be z dot times cosine omega naught times n in the first part?
Yeah, you're right. That's the problem. That's one of the problems, at least, right there. And let's see if this works.
Does it also need to be cosine of omega naught dot times n?
Oh, I don't think so, but that A shouldn't need a dot there. Oh, positive array indices. All right, C is okay. All right. So A has that value. That works. That works. So where's the problem? This is one way of troubleshooting. It may not be the best, but it works for me. What you do is take something you're having a problem with, reproduce it there, and then start culling things out. So I'm going to get rid of this, and I'm going to get rid of this middle term, and C first is that. See if this will run. No. Oh. So this is the problem. That was the problem all along. I'll show you what I mean. When I put that omega in there, it had a 0 index, I think. This should work, but I'm not. And it does. Everybody see that?
Yep.
All right. Who asked about this, by the way? Somebody did.
I think I was the one who asked about it.
Who's speaking? I can't.
Jack is.
Okay, there you are. Now, one of the things about this that's obvious is there's a lot of information that's not being seen clearly because it's all centered here. Now, you notice how it's centered at 3.14 pi, right?
Mm-hmm.
All right, this is a DTFT. So one thing you can do is a shift on the axis. You can take omega minus, and then it would be omega of n, divide by 2. We'll do more of this later. And when I do this, first it'll center it, all right, about 0. And we'll get to the reason why that is, because the DTFT, it's periodic in 2 pi. Every 2 pi, it's periodic. So I want to go from minus pi to plus pi. And really what I'm doing is shifting the centering. And the other thing I want to do is focus on the region that's right around the origin. Now, I think that's x limit and minus 20 comma 20. I'm sorry, 20 comma 20. I think that's it, but I'm not certain. What I should have done is plotted that just versus capital omega right there. Wait a second. Should be, these should be no larger than pi. I'm trying to see why that happened.
That's 2 pi.
Yeah, I know, but look, I'm plotting versus omega ABS of x, right?
Mm-hmm.
Then how can I get values of 20? See what I'm saying?
Well, you're not actually getting those values. The value of the graph stops between 5 and 6, it looks like.
Yeah, I think it does stop. Probably at 2 pi then.
It's a default plot. There we go. So it's 0 to 2 pi. And you can see it's centered here.
Mm-hmm.
And where that is the frequency omega naught. If you take a look at omega naught, it's, or maybe it isn't. Oh, it's adjusted. It's that frequency, sorry. I use this just to plug in here. The actual omega naught was up here, was 10 TS. Wait a second.
I do want to warn you, you have about 5 minutes left.
Thank you.
Yep.
This is a work session for me. I'm trying to answer questions as clearly as I can about this. Let me just say this. Let's move on, all right?
Okay.
I want to go through this with you, the DTFT. Now, for the DTFT, let me just get rid of that. I know I spent time on that, but right now, I think if you have that question asked, others do too about plotting it. So we did it, and I'm sorry it's slow. I'll get better at this as time goes by. All these things this homework are things I want you to do and turn them in by Monday, all right? If you have questions, I've got a 9 o'clock Zoom session with the cabinet meeting tomorrow morning, but after that, probably around 9:30, 10 o'clock, I can get to any questions you have. I'd like to get this in by Monday, and people have been emailing me. I'm going to set up Canvas for this course, and hopefully it'll work right, and you'll be able to drop your assignments off there, okay? I'll make sure I have it up. There have been a lot of problems, but I'll get that up for you this weekend for sure, probably right after this lecture. Now, the other thing I wanted to do is shut that down. Or no, I want to actually do this. I want to go to DTFT, or the DFT, and this is on, you should be able to see that tab, DFT down there. And it's Fourier transforms, or going from a DTFT to a finite number. So first thing, matter of fact, let me go to this one on windowing. This is a better one. So this is applied to my radar class, but it's essentially the same thing. Everybody can see on the screen here, I have synthesis and analysis using the DTFT, correct? Can you all see that?
Yep.
Yes.
All right, this is DFT and windowing. Now, this is not a doable thing in real time because we have a finite number of data samples we're going to collect. With radar is you turn on your receiver and you start catching all the information coming back. You're sampling it, quantizing it, and storing it digitally. Follow me? You have a certain length of time you're going to do that. So you're going to get a data record. Now keep in mind, I have a data record now to work with. It's not continuous time. It's a data record. I took a snapshot over a window of time. Now that allows me to do something. I can take this, right? This right here, And I can say now my samples don't go from minus infinity to plus infinity. They go from 0 to some capital N minus 1. Do you follow me on that?
Yep.
Right here, now I'm going to have a finite number of samples. What that also does in the frequency domain is it takes omega and omega naught, and it says the maximum value that can have is 2 pi. So omega n will have 2 pi. That's the maximum value. By the way, I want to say one thing here. I'm sorry about this, but here, the omega here is R capital omega. Some books do not, they don't make a differentiation. But whenever you see a DTFT or a summation, that omega right there is a capital omega, and it's limited from 0 to 2 pi. Everybody with me on that?
Mm-hmm.
Follow me. So now what do? We say we take this analysis portion down to here, and we're going to create a new functional identifier. It's capital X of K. Now what that is going to be the discrete Fourier transform. It's like the DTFT, but now it has a finite number of data points. It goes from 0 to n minus 1. With me?
Mm-hmm.
Before it went from minus infinity to infinity. That's a lot of points, and we can't do that computationally, so we adjust things. Our total range, I hope you can see this, is 2 pi times k times n. K is a subscript here. N will be over where the sum goes over, and it's divided by n. Now this value right here, this 2 pi, stuff like this, what this really does is take 2 pi. Every 2 pi, the DTFT is going to repeat itself. It divides it by capital N, so it slices up 2 pi and divided by n. That is your delta of capital omega. That's the actual incremental step in the frequency domain. You're summing over n, so that goes away, and the index is k. So k is like the number in the frequency domain you're at. If k was 0, you would be at DC. If k, well, theoretically, you'd be at DC, because if k is 0, this is just 0, right? E to the 0 here. So you're just summing everything. Correct, class?
Yes.
That's the DC value. Now, when you take a look at this, what you're going to notice is a couple things. First, it's finite sum. I have 2 pi over n is the key thing there that's going to be taken to the kn power. Here's the MATLAB code for that. Ruth, are you gone already? No, you got another couple minutes with you.
Yep.
All right, hang on there. Now, when you go, this is the actual DTF of DFT of a signal. It's an example, 1, 2, 2, 1. The only thing it's doing is mathematically just cranking that. It's turning the crank on this right here, and it's shown explicitly. So you can look at that and see mathematically what's happening. But I want to tell you this much. It's really trivial. And now I'm going to show you how to do this on MATLAB, hopefully. Let me go here, and I just want to show you this. Now remember, I don't have time today, but I'm going to show you that what we normally do is have 2 to the n samples, so we can do what's called an FFT. More on that later. If we don't have 2 to the n points, they add zeros until they get a series that will be 2 to the n, and that's called zero padding. That's another lecture. But let's just do a simple example. Suppose I have x equal, say, 1, 2, 2, 1. That's the example basically he did, something like that. And if I want the DFT of that, I'm going to say that capital X is equal to the FFT, not DFT, FFT of X. Now just watch. And you'll notice it has real and complex values. Do you all see that?
Yes.
All right. Now, if you wanted to get X back, and I'll call it XX, you put I FFT of capital X. And now, there it is. That's the inverse. Got me on that?
Mm-hmm.
Mathematically, what it's doing is shown in OneNote. That's the FFT. It's really, he calls it a DFT, but it's the FFT. And then here is, he should have the inverse right here. That's the I FFT, the inverse FFT. That's what I just did. Are you with me?
Mm-hmm.
And there's some more information about this. You can actually see the DFT right here. It just takes the FFT, DTFT, the continuous in the capital omega domain frequency response of the sampled signal over the infinite domain in n, and it samples that at points. And the points are spaced by, you take 2 pi and divide it by capital N, and that gives you the actual spacing in between the individual points. And it just takes this waveform and samples it. That's all it does. Got me on that? I'll talk more about that. Over by a minute, I know, Ruth. Now, here it's simply a plot showing you the DFT of a signal. First, this is the signal. Now, this right here, the top one, I hope you can see where my cursor is. That's simply the signal. It's a pulse, and its on time is, I think it's 10, and its duration is 1,000. So it's got a very short on time with long dwell time. You all see that? Well, what's the DTFT of that? That's like a pulse, p tau of t, right? Well, it's going to be a sync-like function. And if you look here, it is sync-like. I want to say this. This right here is like DC, and this is like 2 pi. But the range normally is to plot it from minus pi to plus pi, and then it'll be symmetric, because this is information that should be on the other side of this thing. And that's the magnitude of it. And here's what happens when you get an FFT shift. Let me finish this lecture with this, and then you can go. If you need to go, Ruth, go. But I want to just show you this. Now, if I have something, I'm going to create this. You don't need to. I'm going to say xx is equal to 1s. And I'm going to have 1 by 100. And then I'm going to say x is equal to 1s, or sorry, xx. This is called collating. And then I'm going to have 1024 minus 100, or I'm sorry, zeros. I hate when it does that. And then just to take a look at it, plot X. I want to make sure what I've got is right. Sorry. Where's my plot? You see it? That's the function. That's a pulse, right? Yeah. Now, this is the last thing. If you got to go, you got to go. I'm going to say X is equal to FFT of small x, and then clear all. Oh, I should have done that. Stupid of me. And then let me plot this. All right, that's what it looks like. All right, that's this. Now you'll notice one thing. This is just it's a mirror image of this about the midway point. All right, so normally what you do is this. It's called an FFT shift. And I'll call XX equal to FFT shift of X. Then I'll plot of XX. Now watch this. Now it shifts everything to a center point. Follow me? That's zero frequency. The way you get the actual value, I mean, to make that zero frequency is you go ahead and say plot, and that's going to be it's going to be n minus n over 2, comma, and I'll talk more about this next. I don't have n. we're out of time. Let me just say this. We can easily shift this here. And that's actually in the homework. And I'll put some notes up, additional notes about this. And then what I'm going to do is give you an assignment so you get familiar with the DTFT and the FFT, so I can talk more about this on Monday, okay? Now, technically I have an office hour now. If you want to stay on and ask questions and let me follow through with this, I'll be happy to do that. But if you have to go, you have to go. And I understand that too. So we're down to 19. If you give me a second, I'll finish this, okay?
Dr. McGinsky, are you going to continue recording through office hours?
Yeah.
Okay, perfect. All right, thank you.
And the recording should still be on, I think. Let me just check.
Where can we find the videos from last night and previous lectures?
I'll send you a link to that. And it was my fault that I didn't record the last one. I do have, I believe, the first one, but it's horrible. Yeah, I'm still recording. These are, by the way, the data record's massive on these things. They don't compress them or anything. All right, back to this thing and how to change it. Let me work in this range. Actually, that was something else. I'm going to work here. So what I'm going to do is take, I'm just going to go here and I'll do it again right here. I had XX equal ones, right, from 1, 100. And then I had X equal to, and I collate with this, the bracket, and I'm going to go from, I'm going to have XX first, and then I'm going to add to it. It has to have the same dimension. So this is going to be zeros, and it's going to be 1, and I'll put, say, 10, 24, minus 100, because I try to keep it, the length of this I want 2 to the n. And then after that, then I'm going to say that capital X is equal to FFT of X. That's the fast, it's really the DFT, and I'll make a comment right here. This is DFT is approximately equal to FFT. Then after that, I'm going to call XX equal to FFT, sorry, FFT shift of X, or of X, pardon me. What I'm doing now is shifting it so everything's from minus pi to plus pi, basically. I'm shifting the data. And then what I do, I only have 4 people left. Okay, I don't blame them. They probably are bored with this, but this is actually useful to see. If you have Octave open or something like that, or MATLAB, you can work with me on this one. And then after that, now I'm going to go ahead and say that this is important. I'm going to call capital N equals the length. This is one command that I like, the length of really X. So that tells me how many points I have, basically. And after that, now I'm going to plot. And now I have, oops, I don't have. I've got to go ahead and say that small, I'll use K. K is equal to 1 all the way out to N. And then I plot, I can plot omega, I can plot K. I'm going to plot K first. And then ADS of XX. So when I do that, just for the sake of sanity check, I get that, but I've got something, I can do that. All right, that's what I have, right? Now we're going to go ahead and shift this frequency axis. So I put K minus N over 2. That'll shift it from negative to positive, the same value. And now you see it's centered at 0, correct? Now, once it's centered at 0, if you want the actual frequency in the omega domain, what you're going to do is say that, well, omega here of k will be equal to 2 pi divided by n, right? And then it's going to be times k. Okay? Now, what I'll do is for this one, I'm going to put omega here and O divided by omega of n divided by 2. And now let's take a look at that. I've got to learn to put these parentheses. Do it again. Y'all see that? Hey, I think I have another meeting. Hold on for 1 second. Hey, guys, I got another meeting. Can I get back to you in about 20 minutes? Y'all hear me?
That works with me.
Pardon me?
That works with me.
All right, I'm sorry. These are kind of important times. I got all sorts of stuff coming up. All right, thank you. I'll be back with you in about, say, 20, 25 minutes, hopefully.
Okay.
Take care. Wait a second.